Okay. Hi. So, like Otto said, we're gonna talk about reactive extensions on JVM. That's not only Java. It supports Ruby, Scala, Kotlin, everything that's on JVM. I work on Android, so I'm gonna talk about stuff in JVM. Also, you have support for Rx in Ruby and JRuby. So, what are reactive extensions? A library for composing asynchronous and event-based programs using observable sequences for the JVM. That's from the Eric Java site. Better description, in my opinion, is this one from ReactiveX site. ReactiveX is a community, I guess, that's building Rx at the moment. So it gets best ideas from observer pattern, iterator pattern, and wraps that around with functional programming. And that's basically what I want to show you today. So my presentation in one sentence is this. What do we mean by functional? So functional part will be lambdas, closures, and all the thing around that. I'm assuming you know a bit about this, so I won't go too deep into this. More time I'll spend on the reactive part, which is asynchronous, push-based, and event-driven stuff. For those of you who know the functional parts, functions are mostly pure. They're not at the end, but in general we stick to the conventions that the functions are pure. If we would want to sum up functional reactive programming in one slide, I guess that would be it. So the lines represent the flow of data. If you start from the left and go forward, and the gray boxes are the high-level functions that manipulate data and output them. What's the problem that we want to solve with reactive programming? For example, in Android world, you want to do a lot of stuff on background threads, because if you do it on main threads, network calls and stuff like that, users won't be happy. So we have a lot of that in our applications, and majority of times you will get data from different sources. So what this means is that you have like nested asynchronous calls to network or something like that. And if you're not careful, things can get really messy really quick. If we take this example, we have a simple method that returns some data. We assume this data will be fetched quickly. I don't know, from memory, from cache, from whatever. So we may make a regular imperative call to it and get data back. At some point, someone changed the structure, and in the background you have to fetch it from the web. Now, if you want to make this asynchronous, you will have to change the signature of the method, which is for, I don't know, potential API user or something like that, it's not ideal. Then you start to do something like that. You put callbacks in. You start to use features or promises, like they're called in some languages. Then at one point you have list of features because you return a list. And again, it's not nice, it's messy, you have nested calls, and life gets painful. So we present observable. Observable is an abstraction over iterable, or it's a tuple of iterable in the background, but it's not important. And with this, we can easily move from synchronous to asynchronous world. Since we are asynchronous, we need to have a terminal state. So you don't get result right back, so you have to wait for it. So that's why we add onError and onComplete methods or callbacks. The main difference between iterable and observable are that iterable pulls data, where observable pushes them down the stream. So with iterable, you create the data and and then when you want it, you pull it from them. Whereas observable, when you want the data, you subscribe to observable, and only then observable starts to work and pushes you down data when it gets them. Here is an example. On the left, it's iterable, and on the right is observable. So as you can see, not much has changed. So in Java, it's Stream API, these high-level functions were added, like skip, take, map, stuff like that. Other JVM languages have them for years. So with observable pattern, everything regarding similar to this is added. The only thing that changes basically is in iterable you have for each, which is a blocking. By definition, it's a blocking event. Where on observable you have subscribe, which is asynchronous. So you don't block. You have option to convert observable to blocking with for each, but yeah, you lose all its benefits. When we want to represent how we get data, you can do it like with 4 states. First is synchronous scalar values. So that's everyone's been using this first time they start programming. You get your data back, you do whatever you want with it, and that's it. With multiple values, it's pretty similar. You have multiple values just for each them. You can manipulate them, no problem. But when we go to the asynchronous world, for single values, future is I guess really popular. And first thing you do when you start programming, you block on it with .get. So you didn't really do much here. You basically still are synchronous. That's a problem and a really big pain in the design of the feature, because again, when you go into the nesting stuff, it gets even messier than before. So in Java 8, they presented composable future, which is way better because you can subscribe to it basically or listen to it, and you get a callback when operation is done. Guava library for Java has a similar functionality, but it's called listenable feature. But yeah, everyone's naming it differently. And then we have Scala. Again, feature. You can subscribe to it, and you get a nice callback. Basically the same than in Java, just another different naming. I'll stop here for a moment. So this at the end is very similar what you wanted to achieve, but you only get one value. So that is cool if you take like one network request and get it back and you're done with it. Really useful, really fun. But when you have multiple values, again, like stream of data or something like that, you can work with that. So here it comes in an observable. Basically the same principles with feature, but you can operate on vector data, so you can operate on multiple values. Like I mentioned before, you have this high-level function calls, like here, for example, map. Then you can manipulate data on. The only thing different from feature here is that observable is lazy, so it won't do nothing until you subscribe to it. I'll try to go into code examples, the simple ones. The first thing you do with observable is create one. So if you have synchronous observable with single value, so that's when you're working with observables. I've been talking till now about asynchronously, but when you're working with them, you can decide on yourself, or the one that will be using your API call or something, whether he wants to consume data synchronously or asynchronously. And that really gives you a lot of power, I guess. So basically, creating an observable, it's just a function that passes in observer, and then you have to call onNext to emit data through the pipeline. And at the end, you have to have onComplete on error. So you have to have exactly one terminal state. If error occurs, you call on error. If you're done with the data, you call onComplete. Moving on to asynchronous single value. So this is the same as the previous example. You get location and pass it on to the stream, but you do it asynchronously. In the production code, you will never do something like that. So here, for example, you have Java executor that is doing work on a separate thread. In the real world, you would handle this differently. I'll mention later how. But this example is to show you that basically in observable, you can do whatever you want. You can do it synchronously, asynchronously, but yeah, not recommended. And then if we move to multiple values, it's basically the same thing as with single value. Just you call onNext however many times you want. You can call 0 or n times. 0 is acceptable value too. But again, whenever the first time you get an exception, you have to call on error. and stop streaming the data. Otherwise, you'll break things. Same as before. Multiple values asynchronously. Fetch it, call on next, fetch it. So resolve location could be a really long operation, and this would be fine on your UI thread. The other part of observable is subscription. So we only have asynchronous subscription. You will always receive data asynchronously. It could be on the same thread, but you will always receive them asynchronously, with a few exceptions, but we won't go into that. Basically, when you subscribe, at the top you add your on next, where every value that you emit in observable will be passed in. The second function is on error. So if an error occurs on your stream, this will be called. And the last one is on complete. The on error and on complete functions are optional, so you can leave them out if you're just interested in on next calls. And again, with this picture. So stuff that I've been talking about now are fun but not that useful. So what we're missing are the gray part. So the high-level functions that you can manipulate data with. These are some of the most common examples. So you can transport, filter, combine data, and then for concurrency, before I've been talking about not doing asynchronous stuff in observable directly, you can do it with concurrency methods that are observe on and subscribe on. With this one, you can actually tell, I want you to do the things that you need to do on this thread or on that thread, and return the data on whatever thread you want. And then at the end, of course, we need error handling. We've seen a basic example with on error call, but these are more advanced. I'll talk about them a bit later. Going into a few examples of these high-level functions. I guess first one is create. I think we've covered this basically on next. If you go step by step. No, okay, sorry. Let's look at the merge. So merge is an operation that combines two streams of data into a single stream. What's important here, that both top two streams of data are of the same type, and then you can merge them into a single stream. This is an example. So you have two observables, both return data type. You merge them together, and at the end subscribe to them and print out data. So these are the observables those at the top are marble diagrams. We use them to represent the flow of data. So these two observables are represented as these two lines in marble diagram. Every bubble on it is on next call, and X is a terminal state of on error, and the straight line is a terminal state of on complete. Merge operation, that's actually part of that high-level function that merges observables into single observable. And in the code is represented here. And at the end, we get an observable that we get out. So we see that in the first observable, there was the third event was terminal state on error. And in the end observable, that's where it stops. So merge figured out that there was one terminal event that was on error, so it doesn't continue and propagates that up. So if the second observable would fetch something from web, they could stop it. They would know, merge would tell them that they don't need any more data, and it would stop. And yeah, the final result in the code. Next one is zip operation. That is basically the same thing as merge, just when you have two different types of data. So two observables with different type. Same as before. These are observables. One has the data, one emits data, one emits strings. We can just simply merge them together because at the end we need one observable that is of one type. And if we have data in strings object, we can do that. So we merge them again. These are the observables in the marble diagram. And zip operation basically gets both items from both observables. And you can then do whatever you want with them and emit them forward. So in this example, this is GUI code. We get, these are two observables, and then we get two items, for example, this one and this one, and we create a tuple and emit it forward. Again, we get observable that outputs multiple tuples, and at the end we print them out as one at a time. Error handling. So, very important part of Eric Java or reactive programming in general is error handling. We've seen on error method at the beginning, and this is basically the same thing if you would put a try-catch block around the whole code you write. Can be really useful, but in some cases you would need something stronger. For that we have on error resume next, and this is basically when a terminal state happens on error state. You start emitting data from different observables. So, for example, if network request would fail, you would start emitting data from your cache or something. In code, this looks something like that. So if we get on error in get data B sequence, on error resume will kick in and start emitting data. Not much to, yeah, important part, if you do on error resume next, on error in subscription down here won't be called, because this one will just emit its data and finish successfully. The next part of error handling is on error return, and then that's just basically the same thing, but you just emit single value instead of stream of data of values. This is useful one. We use it often, and the stream of data is not really that useful because you usually don't have that much data locally or somewhere else that you could fetch. That's it. Questions?
Is the zip operation blocking or?
Nothing's blocking. So, except if you call for each on observable, that is definition of for each function is that is blocking. The main part here is that when you call this subscribe, everything in observable, you can have multiple high-level functions here, and everything in here will be non-blocking. Just this part, these two functions are actually blocking, but they're just the callbacks. So here's the part where we break the immutability part of functional programming. So no, it will not be blocking.
What about back pressure?
Yeah, I left back pressure out because I didn't want to be too long. Zip operation is a great example where back pressure can be useful. So if we, for example, if get data E observable emits like millions of events, and if get data E emits bunch of events and get data B just emits single event, and then for a long time nothing, you will have a problem because everything that's in get data E will have to go in memory until the get data B emits another item so they can be zipped. And yeah, here's where the back pressure starts to be useful. Basically, in the top level, you are working like, I don't know the method called, but here you would say, give me another item. And at that point, both get data A and get data B will get you another item. And when you process that data, you say, okay, I want another item, and then another, and then another. That's the high level of it. It's good enough for most cases, but if you really want to, if you really need some special case or something, its implementation underneath is really abstract, and you can do your own implementation fairly quickly. I hope I answered your question.
Yeah, so you're using Java 8 functional syntax here, but if you're using this on Android, you don't actually have Java 8, you have Java 6, I think.
You have Java 7, but yeah.
Java 7 on Android phones.
Yeah, RX support Java 6, so this is not an issue. Instead of lambdas, you call like new action one.
Yeah, but you would get like a ton of anonymous in a classes.
Yeah.
And it's
Yeah.
probably not as nice as this.
Yeah, it's not, but what we do, we use a library called Rattler Lambda that compile times, so you get this syntax, and then compile time, this library generates anonymous classes. So the code still looks good, and you can do it on Java 6. Anything else? Thanks.